Hello, I'm Richard with EV4U. In this episode, we will discuss AC circuit design and wiring, as well as looking at some sample off-grid power systems. We start by determining power requirement, the load, and the location of the loads. I recommend following local building codes when wiring a cabin. Standard practices for van and trailers are available online. Remember, this is not a how-to guide, but a big picture reference as to what you should be aware of. Safety first. If you don't know something, ask someone who does. Typically, you will have a separate circuit for each load. Consider the power requirements of the load and the distance from the circuit breaker panel. Using Joule's law and online guides, you can select the proper gauge wire and fuse rating for the load based on the power requirements and the length of the circuit run. Remember Joule's law, power equals volts times amps, as well as volts equals power divided by amps, and amps equals power divided by volts. Most off-grid setups will use either 15 amp or 20 amp AC circuits, with 15 amp being the most common. In general, a 15 amp circuit will require 14 gauge wire, with 12 gauge wire typically used for 20 amp circuit. All of your outlets and switches should be rated the same as the overall circuit. So if you're using a 15 amp circuit breaker and your switches and outlets are 15 amp on that circuit, don't throw a 20 amp one in the mix. Typically, a separate circuit is used for each larger load. However, one circuit can power multiple outlets, commonly called convenience outlets. It is recommended that the breaker box be close to the inverter. The wiring from the inverter to the breaker box must be able to handle the total system power requirement. As mentioned in previous videos, you need to create a schematic diagram and any necessary notes. Be systematic and methodical in your design. For each circuit, start from the breaker box, move to the switch, and onto the load. For most AC circuits, we want to use solid core wire, often called Romac, after one popular brand name. Use NM cable, which is designed for interior use in dry locations. NM is the most common type of wiring in modern homes. It consists of two or more individual wires wrapped inside a protective plastic sheathing. NM stands for non-metallic, which refers to the flexible, typically thermoplastic sheathing surrounding the cable. We discussed the proper way to connect AC switches and outlets in a previous video. With AC circuits, there are three wires used, typically a black wire for the hot, white for neutral, and green or bare copper wire for ground. They must be properly connected. You can refer to our previous video. In addition to having an inverter provide your AC requirements, battery-powered inverter, you may also want to use a backup fuel-powered generator. With a trailer or van, you also might want to take advantage of the grid, or shore power as it's called. When using shore power or a generator, you should use a transfer switch. Transfer switches are available in either manual or automatic. A transfer switch basically switches the source of your AC input power from your battery pack powered inverter to a fuel powered generator or shore power. The transfer switch is like a T-junction. On one side of the top of the T is your battery powered inverter. On the opposite side is the fuel powered generator inverter or shore power. The bottom connects to the circuit breaker panel. The transfer switch selects between input from the grid, shore power, fuel powered generator, or input from the battery pack powered inverter. Only one source will be connected to your circuit panel at any one time. Remember, every circuit includes a hot line, neutral line, and a ground line. Some battery-powered inverters include an internal charger that allows you to charge your battery pack from a generator, inverter, or the grid. Here's a sample of a off-grid power system schematic showing your solar panels, your solar charge controller, your battery pack, an inverter, transfer switch, your 12-volt fuse panel, and your AC distribution panel. This is a sample of my cargo trailer conversion schematic, which features 16.5 kilowatt hours of batteries. It was built with components that I already had on hand in order to save money. There are three separate lithium iron phosphate battery packs plus the EcoFlow Wave 2 battery. One battery pack consists of four Battle-Born 12-volt 100 amp hour batteries all in parallel. The second battery pack consists of two SOK 12-volt 206 amp hour batteries in parallel. The third is a custom-built battery pack consisting of 8 CALB 180 amp hour cells with a 4S 2P configuration, providing 12 volts and 360 amp hours. The last battery is from EcoFlow and mates to their Wave 2 air conditioning with heater. It has a 1,159 watt hour capacity and connects directly to the base of the Wave 2, so it doesn't power anything else in the trailer except the wave tube. The trailer's power system uses a 3000 watt pure sine wave inverter with a built-in 75 amp charger. There is a 30 amp shore power connection and a manual transfer switch. There are two solar charge controllers. One 60 amp controller is connected to the 8 100 watt solar panels on the roof of the trailer, and there's also a 100 amp solar charge controller for use with the 1600 watts of solar panels mounted on the bed of the pickup truck. This gives a combined solar charging system of 2400 watts. This unique off-grid system powers 2 water pumps, LED lighting, 2 vent fans, 4 USB charge ports, security cameras, an alarm system, 53-quart refrigerator, and a 53-quart freezer, power bed lift, 3000 watt inverter, 4-gallon electric water heater, microwave oven, dual element induction cooktop, toaster, hair dryer, curling iron, etc. Please note that the above 12 volt, the schematic is shown as a 12 volt system only because those are the components that I already owned, and each of these components were taken from some other previous project. If I were starting from scratch, I would have designed a 48 volt system. And that is also what I recommend, for a system of this size. If building this from scratch, it would be a smaller, lighter, more efficient, and less expensive system if you go with the 48 volt recommendation. All-in-one system are systems, refers to a device that has an inverter and a solar charge controller in one package unit. All you have to add is a battery and solar array. You might want to check out the EG4 48 volt off-grid option. It can also refer to what is commonly called a solar generator. Solar generator typically refers to a battery pack with a built-in inverter and solar charge controller. In this case, all you need to add is a solar array. They are available in a variety of sizes from a couple hundred watt hours to thousands of watt hours. They can be used as stationary systems or mobile systems. You might want to check out the EcoFlow Delta Pro. An all-in-one system is as simple as it gets. With an all-in-one system, you can design your off-grid cabin, trailer, or van so that your utility panels simply plug into the all-in-one system. And I've provided you with a sample schematic. Well, that's it for this video. Thank you for watching. Please like and subscribe, and I hope to see you in the next video. If you have any questions, please leave them in the comments below.